Hello, ladies and gentlemen. My name is Abdurrahman Ali. Today, inshallah, I'm going to solve question 6 for analyzing and lecture 7 for fluid power fundamentals. The question says, a 5 centimeter diameter horizontal jet of water with a velocity of 40 meter per second relative to the ground strikes a flat plate that is moving in the same direction as the jet at velocity of 10 meter per second. The water splatters in all directions in the plane of the plate. How much force does the water stream exerted on the plate? So now, let's first draw the flow body diagram so we can understand more and more of how to solve this question. So we are having the jet, okay, it is splashing water, and we are having a plate, okay. So the water is going with 40 meter per second, it is telling you here, and the plate, when it hits the plate, it is also moving in the same direction, okay, with a velocity of 10 meter per second. And we know the diameter of this one is D equal to 5 centimeters, because it's telling you here. So now, after we put all the information that we have, let's try to find how much force it needs, this one. First of all, we need to get the mass flow rate. Mass flow rate, you know, the equation for the mass flow rate is density V times area. So we know the density of the water is 1000. We know the velocity, which is 40 meter per second, but we don't know the area, but we are having the diameter, so we can get the area. So mass flow rate equal to 1000 times 40 times, we know the area for this shape is equal to pi d square over 4. So it's going to be pi times the diameter. We know it's in centimeters, so we have to convert it to meter over minus 2 d square. Don't forget the square, that's one, over 4. So our mass flow rate is going to be 78.5 kilogram per second. So I have to put it in the square because we're going to use it later. And now we know that our relative velocity, you know, RV equal to, we are having 40. After it hits the plate, it became 10. So our value after losing this one, we can say 40 minus 10 equal to 30 meter per second. Okay, so this is our relative velocity, which is VR also. So now we need to find the mass flow rate for the jet itself. So we know it's mR over the mass flow rate equal to, we know it's relative velocity over velocity. So in order to find this one, we need to rearrange the equation to find the relative mass flow rate. So it's going to be mass flow rate times VR over V. So mass flow rate is going to be, we know the mass flow rate, which is 78.5 times the velocity VR, okay, which is 30 over 40. So we gonna end up with 5 multiplying this and divided by this, we're gonna get 7.5 kilogram per second. So after we analyzed and fixed and we found everything that we need, now let's go to our final equation, which is said summation of all forces on the x-axis equal to summation of, the outlet, we know beta, times this one, minus, this is mass flow rate and velocity, the summation of all forces, beta, and the inlet, which is mass flow rate, and v, velocity. We need to find the force. Okay, so let's write force on the x-axis equal to, we know we don't have anything on the outlet, so it's gonna be 0 minus. Now for the inlet, we know the mass flow rate, we got it is 58.875, and we know the velocity in the inlet, or the relative velocity in the inlet is 30. So the force is going to be minus 1766.25 Newton. The negative, it's showing that the force is going to the left. So here is the force. That's the force, or how much force does the water stream exert on the plate. Thank you guys for watching. I hope inshallah to see you next time.